Hey everyone, welcome to Chapter 2, Section 1, Part 2 video. We're solving systems of equations with substitution, this time with 3 variables, but you'll notice I wrote with 1 solved. So I'm giving you 1 answer to start off with. So you might actually find that this part is easier than Part 1 because you're given a variable to begin with. So like looking at number 1, I have x equals 4. That means every time I see an x, I'm going to plug in the number 4. It's pretty easy, right? So what you want to do is you want to start with the equation with 1 variable and then move to the equation with 2 variables, and then eventually you move to the equation with 3 variables. So I'll take this 4 and I'll plug it into this one first. So I'm trying to say don't plug it into this one, not yet at least, okay? So for the first step, you want to work with the equation with just 2 variables, because if you work with the equation with 3 variables, you only know the answer to 1 right now, so it wouldn't really help you. So if x equals 4, then 4 plus y equals 7. So you could probably do that in your head. 4 plus 3 equals 7, but since I'm a math teacher, I'll show my work, and so I'll have to minus 4 to the other side. 7 minus 4 is 3. So now that I know my x and my y answer, I can turn my attention to that 3 variable equation. So I will take the 3 and plug it in for y right there. And then I'll take the 4 and now I'll plug it in to the third equation. Okay, so I have 2 and then x was 4, so 2 times 4 plus 4 times and y was 3, and then plus 2z equals 18. So I'm going to multiply. I'm going to do 2 times 4. That'll be 8. 4 times 3, that's 12. Plus 2z equals 18. Now I can combine like terms, the 8 and the 12. They're just plain old regular numbers. I can't combine them with the 2z. I can't say 8 plus 12 plus 2z equals 22 or 22z if not all 3 terms, if all 3 terms have different, what am I trying to say here? If these two don't have any letters with them, you can combine them. If this has a letter with it, you can't combine it with these two. It'll just stay added on like that. That's what I'm trying to say. So they're not like terms. But what you can do with the 20 is you can minus it to the other side. Alright, so 18 and 20 are regular numbers. They can go on the same side as that. 18 minus 20 is negative 2. So I have 2z equals negative 2. So if you have a number by a letter, they are married together because they are multiplying. So the only way to split up a married couple is by divorcing them or dividing them. So I'm going to divide them by 2. And so I get z equals negative 1. And then once you've done that, once you have your answer for x, y, and z, well, you're done. Just officially, we want to restate our answer as what's called an ordered triple. So an ordered pair is x comma y. So an ordered triple would be x comma y comma z. So I'll say 4 comma 3 comma negative 1. And then in case I lost you, I'll label it like that, x, y, z. So just always restate it as an ordered triple. And yeah, that's it. So I got 2 more examples that'll go just like that. So example 2, I'm giving you the y variable. So you're going to take 12 for y, and you're going to plug it into the equation with just 2 variables in it to start. So I'll work with that equation. So I have 4x minus 2y, so 2 times 12, equals 8. What's negative 2 times 12? That'll make negative 24. And then bring down the 4x and the 8. So as I was saying before, I won't combine these. I won't say 4x minus 24 equals negative 20 or negative 20x. This has an x, that doesn't. So they stay, this is as simple as it gets. But what I can do is I can add 24 to the other side. And so bring down the 4x. 8 plus 24 is 32. And so 4 is multiplying by the x. 4 times x makes 4x. So you need to divide them apart. and you get x equals 8. So now I have 8 and 12 that I can plug in. So I'll take the 8, plug it in there. I'll take the 12, plug it in there. And then I'll rewrite my equation with those plugged in. So I have 6 times 8 plus 3 times 12 minus 6z equals 18. So do your multiplication. What's 6 times 8? That's 48. What's 3 times 12? That's 36. Carry down the minus 6z equals 18. And then combine like terms, which are these two numbers. Can't combine it with the minus 6z because that's the only term with a letter. So 48 plus 36 would make 84. Minus 6z, bring the rest down, equals 18. So because I can't combine it, that means I'm going to subtract it to the other side because it was a positive 84. If it was a negative 84, I would have added it. And then bring down the negative 6z. 18 minus 84 is negative 66. So, as a teacher, I noticed that kids do problems like this right most times. 4x equals 32, they're like, oh, divide. But when I give them a negative number, they'll want to add it to the other side because they think negative add. But remember, if I took that negative away, I would just have a positive 6z and you'd be like, okay, divide by 6. So if I just put a negative by it, why would it turn into an addition problem to get rid of it? It's still multiplying. It's negative 6 times z. They're married together. Anytime you see a number and a letter together, they're multiplying negative 6 times z. So you still have to divide it, even though it's negative. Just divide it by that negative number. So, negative 66 divided by negative 6 is positive 11. And we've now gotten an answer for x, y, and z. We had x was 8, so I'm going to write my ordered triple now. 8, comma, y was 12, that was given, and z is 11. And that's number 2. Number 3, if you look at the bottom equation, I have 3x equals 18. So I didn't blatantly give you the answer, but 3 times what number is 18? 3 times 6, right? But, since I'm a math teacher, I'll show my work. I'll divide both sides by 3, and I get x equals 6. So I'll turn my attention to that 2-variable equation, and I'll plug in the 6 for x there. So I have 4 times 6 plus 6y equals 60. So do 4 times 6, that's 24, plus 6y equals 60. Again, I won't combine 24 plus 6y and say it's 30 or 30y because the 6 has a y with it, the 24 doesn't. So what I'm going to do is I'm going to minus the 24 to the other side. And I'm going to get 6y equals 60 minus 24 is 36. So 6y means 6 times y. So they are married multiplying together. So divorce, divide them apart. Divide by 6. And you get y equals 6. So now I have an x answer and a y answer. X equals 6. I'll plug that into the top equation, the 3-variable one. And I'll plug in y equals 6 into that same equation. So I'm going to write 4x. So 4x was 6 plus 6y, and y was also 6, plus 5z equals 70. So now I just multiply. 6 times 4 is 24, 6 times 6 is 36, plus 5z equals 70. Combine your like terms, which is just the 24 and the 36. 5z is not alike to those because it has a z and these do not. So that's going to make positive 60 plus 5z equals 70. So I won't make 65z, but I will, because they don't have the z's in common, I will subtract the 60 to the other side. 5z equals 70 minus 60 is positive 10. And so 5z means 5 times z, so the opposite of that would be divide by 5. And I'm going to get z equals 2. 10 divided by 5 is 2. And so I'm going to write my ordered triple. It was 6, 6, 2. X, y, z. And that's going to wrap it up for the notes. So make sure you hit that like and subscribe button on your way out, if you feel like it. And thank you for watching. Bye-bye.